This little video covers week 4, the example. I'm going to set my type 1 error rate at 0.05, which is 5%, which means that I'm going to acknowledge that 5% of the time I'm going to wrongly reject the null hypothesis. I hypothesize that the average length of the produced ignition switches is 14.5 centimeters. To test this, as usual, I collect data. I measured the lengths of 30 of those ignition switches that I collected. The average length of that sample is 14.41. Standard deviation is 0.2. This comes from last week. Does the data support my hypothesis? That's new. Last week we did a confidence interval. This week we're testing the hypothesis. So we've got two options. We can use the critical value or the p-value method. Here we are in StatCrunch. Let's do the p-value method first, because that tends to be the easiest. Stat, t-statistics, because we do not know the population standard deviation, we'd use t's. It's one sample because it's just ignition switches. I'm not comparing the output of two machines. It's just one ignition switch. With summary, because I'm not actually giving you the data, I've already summarized the data. This should look familiar from last week. Sample mean is 14.41. Sample standard deviation was 0.2, and sample size was 30. Next. Now we're going to do a hypothesis test. Last week we did confidence interval. Now we're going to do a hypothesis test. The null mean is equal to 14.50 centimeters. Our research hypothesis was that it was equal. Therefore, the alternative is going to be not equal. And the alternative is either the research or the opposite of the research hypothesis. If the research hypothesis has the equals part, then the alternative is going to be the opposite. Otherwise, the research and the alternative are going to be the same. And we hit calculate. And then through the magic of computers, mu is the population mean. Our null hypothesis is that mu is equal to 14.5, which matches what we thought we wanted. The alternative, here is h sub a for alternative. In the book, it's h sub 1. Mu is not equal to 14.5. That also matches what we expected. Sample mean was 14.41, which is what we put in there. Standard error is the standard deviation divided by the square root of n. Degrees of freedom, since it's a one sample test, degrees of freedom will be n minus 1. The t-stat is what we observe, and we'll use that when we do the critical value method. And the p-value is what we're going to use for the p-value method. Here the p-value is 0.0199. Since p is less than alpha, since 0.0199 is less than our 0.05, we reject the null hypothesis and conclude that the average length of the switches is not 14.5 centimeters. If we needed to do the critical value method, this test statistic here, negative 2.4647515, that is the observed test statistic, and we need to compare that to the critical value. Critical value from the table is 2.045. Since this is less than negative 2.045, we reject the null hypothesis. We are in the rejection region. How do we get that 2.045? Stat, calculators, t. Degrees of freedom is 29. We don't know what this value is, so we're going to delete it. But we do know what this value is. That value is 0.025. And we do want to keep this to be less than or equal to. Compute. There's the negative 2.045. That is our critical value. Hope that helps. Good luck.